The production of this program is made possible thanks to the support of the following and viewers like you.
The odds are good that you live on the coast if you live in North America. In Canada, about 40% of us live within kilometres of our vast coastline, and in the US, more than 52% of people live within miles of their coast. What happens on the waters that lap against our shores matters. According to Fisheries and Oceans Canada, we rely on our oceans for food, jobs, clean air, and our social fabric is woven into the vast history of maritime and indigenous traditions. What happens at sea is, however, a bit of a mystery. Key to understanding what is happening along our coastline is data, real-time data, not just modeling or satellite imagery, real data gathered from the ocean and beamed up in real time. Enter Victoria-based MarineLabs Coastware ocean buoys that are now providing critical information to ships' captains, coastal communities, port authorities, and governments. Data that helps to ensure safe passage, data that helps ports react to changing weather, data that ensures coastal communities have time to batten down the hatches in advance of storms and rogue waves. I invited Dr. Scott Beatty of MarineLabs to join me for a conversation that matters about the importance of real-time wind and wave data and the long-term insights that information provides to coastal communities as they plan for changing climatic conditions. Scott, welcome.
Great to be here.
How big of a challenge is this to be able to actually get real-time data along the coastline of, let's just say, British Columbia, let alone the rest of Canada around the north and over to the Atlantic?
Well, if you've tried to put a sensor out in the water before, you'd feel this challenge. The ocean's actively trying to destroy everything that you put there, from breakwaters to markers to different kinds of buoys, whatever sensor things that are going in the ocean. And so it sounds simple, but it is quite challenging. And so the challenge is exciting to us, though, as a company, building technologies that can be rugged enough to handle those types of conditions and be reliable for coastal communities and industries.
Okay, how have you addressed that challenge?
So we build solar-powered units that are about this big, that have directional wind sensors and wave sensors, GPS, and a bunch of computers on board processing data, and we treat them like NASA would treat a Mars rover. Tons of testing, we put a lot of investment into how rugged they are, and then as they get commissioned through our lab, we are 100% certain that these things are rugged enough to then be deployed and last a long time out at sea.
When you deploy it, is it to a specific location and you hope that it's going to stay within that region, or are these roaming up and down the coastline?
At this point, they're not roaming. We tend to keep them on a mooring. So I can back up a little bit here. Canada has the longest coastline in the world. Yes. And there's various ways to measure that. Obviously, it depends on how long your ruler. This is an age-old
right.
challenge. But let's pick a standardized ruler. We still have the longest coastline. And we have only 41 measurement buoys that are government-run. That means that along the coastline there are huge gaps between these buoys, and which means those are underserved areas where there could be a lot more data. But at the same time, the Coast Guard operates 10,000 floating navigational aids. So all of these navigational aids, the red and green markers that are marking channels and rocks, very, very important part of the system for marine safety, those could all be real-time data buoys. So that's what we see as a major opportunity, where we install our sensors on top of those and then provide a real-time data source for the ports, pilots, coastal engineering, et cetera.
So you put the buoy in the water. What does it start to measure, and what's the process by which you receive that information?
Sure. So we install our sensors in the water. That could be on a navigational aid, or it could be on our own buoys, which we also deploy. And the unit calibrates as soon as we deploy it, and then it transmits data over cell networks. And if there's no cell network in the region, it transmits data over satellite. And with this redundancy, that means we can get great reliability so that there's a backup in case cell networks go down, like we saw in Atlantic Canada during Hurricane Fiona. So it transmits all that data over cell primarily with backup to satellite, and then the data makes it to our cloud where we're processing it and then displaying it on a system that works well for the maritime industries and for folks that need the data.
You talk about the East Coast. Of course, your equipment was in place as Hurricane Fiona was zeroing in on the East Coast, especially Newfoundland. At what point did you start to be able to transmit information that said, okay, we've got a major storm coming directly at you?
We were just starting a pilot program before Hurricane Fiona, so we got lucky in a sense with timing. And we had a few of our units on navigational aids just deployed a week and a half before. And we noticed that the conditions were getting worse and worse from the southern buoys as you move to the north. And so we saw this wave of super high winds and really large waves hit, and then hit a little bit later at the next northern one, and then a little bit later up in Placentia Bay, way up north in Newfoundland. So lots of data came from that. It was a very interesting thing to be a part of, and I think it fed into the Coast Guard's awareness of what was going on in terms of response, but there was a lot to do, and so our data maybe will be better served for them as a post-analysis later, just because we were so new in this pilot program. But the way we see it is that once this data is fully integrated into the marine safety system, it will be able to be relied upon a lot more for incident response and that kind of stuff.
Will you then be analyzing what the data is telling you, or are you going to be supplying raw data to Coast Guard and to coastal communities?
We do a little bit of both. So because we're sending this data onto the cloud, we have an opportunity to analyze it and generate other insights from that data. So we can generate reports of statistics, like what are the maximum winds ever seen in this one location over a period of time. That can then be combined with modeling work to say what should the worst storm in 100 years look like. And with climate change, that all those statistics are changing because storms are getting more volatile. And on the BC coast, same thing. There were incidents like the White Rock Pier in 2018 that completely taken out by a strange wind direction that wasn't really designed, wasn't part of the design or used to generate the design of that pier, as far as I understand. And so there was a major incident that happened there. Thankfully, the man was saved off the end of that pier.
Yes.
But marinas are starting to feel this impact as well, and new kind of coastal harbor projects, new port projects, all of that. The latest data and then the statistics moving forward need to be used to figure out how to adapt and how to invest to adapt.
I got to get you to hang on for a second while we take a quick commercial break. We'll be right back.
The production of this program is made possible thanks to the support of the following and viewers like you.
Because any of the planning that had happened in the past, in essence, would have been anecdotal. People said, well, this seems to be the prevailing system or way in which weather moves through here. But now you're going to be able to give them real-time information.
It depends on what was done and when a project was done. There is a sort of standard practice with coastal engineering. So coastal engineers, they typically create a model of a region and then try to validate the model and then use that model to predict what the wind and wave will be at a given spot, say a pier or a marina. But with our data built into that, it's now a lot more valid, a lot better certainty on what those statistics will be. So that's a big aspect of what we do, is collect long-term data and then provide that to coastal engineers who need that.
So one of the challenges facing so many communities is, well, are sea levels rising and at what rate? And therefore, how do we plan to mitigate what the impact of that might be? But also, how do we plan to make sure that we're not building in the way of coming coastal sea levels?
Yeah, it's a major challenge all over the world. In some areas in the world, there is the land rising and the sea level's rising, but the land's rising faster. So sea level rise isn't as much of an issue because it's net of the land movement. But in other areas, the land is actually going down, subsiding, and then that's making sea level rise even worse. And so folks, this sort of standard number right now is 0.5 meter by 2050, 1 meter by 2100. Those are sort of rough numbers that came from government studies. And it doesn't sound like much, 0.5 meter, but when you add weather volatility on top of that, where you've got storm surge that increases that height a little bit more, and then you've got big waves that then add on top of that, that's where you start getting flooding like you might see in White Rock, Surrey, or some of these other low-lying areas. Even Comox on Vancouver Island can have issues with storm surge. And so data to kind of build up statistical basis for that is going to make a big difference on how do we invest? How do we invest in the seawalls that are going to protect from that? What infrastructure are we going to invest in? And if the data used to design that is uncertain, that means you're going to build a structure that you don't know if it's resilient to the future conditions. And so what we're saying is bring certainty to that data, bring certainty to that design, which allows you to be more certain that you're resilient to climate change.
So is that what the real long-term value of this system is, more than just saying, okay, we're going to help keep commercial shipping lines informed as to what's happening at sea? Is it really the importance of how this is going to help us to plan appropriately, because we've got real information that's showing the incremental rise of water levels, and then that, as you say, couple that with storm surges?
Yeah. So we've got two main value propositions as a business. The first one is that we're providing real-time awareness for port operations, for vessel pilots, for those mariners out there who need to make decisions. And where should a ship be? Where should it be anchoring? What approach should it take? Should a pilot climb on a vessel or not? All of that stuff. That's a sort of real-time value proposition. And that's really where our first foothold is. That's where we've been able to help a lot with the ports and with the vessel pilots. But as this network spreads, as we start getting more and more of these sensors toward that thousands number that I mentioned before, now this data set becomes a lot more useful for a systemic climate adaptation investment. So that's where, so I see it as a timing thing. Yes, absolutely, that is where the long-term value is, but we as a business need to go and provide short-term value on our route to getting that network to the size that we need.
How many you got in the water right now?
We've got 36.
Yeah? And growing?
And growing. We will have 100 by the end of the year. We're looking at deploying many more along the Pacific coast. And then we are actively expanding in the U.S. as well. So we have a pilot project starting in eastern seaboard in the U.S. Quite soon.
This is our second break. We'll be back in a moment.
The production of this program is made possible thanks to the support of the following and viewers like you.
Okay, so I'm fascinated by your business model. How do you make money doing this?
It's a good question. So the best way to answer it is to say a little bit about what the backdrop is before us. So before us, government would invest budget in a technology where they'll deploy a really large buoy, maybe half the size of this room, put it along the coast. It's one of those 41 that we're talking about, which means it has to be far away. There's big gaps between them. And they update about once an hour, and this data is publicly available. But if the buoy has an issue, which they often do, then there's only 1 or 2 ships that can service that buoy, and it's down for a long period of time, sometimes from one winter all the way to the end of a summer. So we're talking about downtime that is really, really problematic for industries to safely move our goods into the country and out of the country. And so with what we do, there's an opportunity there for ports to say, look, that downtime and that location of that buoy isn't really working for us. What we can do is have MarineLabs install some gear on local buoys or on some new buoys, and then we just pay a subscription fee for that, and MarineLabs handles all of it. So the benefit of that is the ports don't have to be buoy experts. They simply receive the data that helps their operations, which is what they need. So that's the business model, subscription basis on data, and we own the hardware effectively.
So to fully understand this, you don't even have to have the buoys, anchor them, and so on. You're attaching to existing buoys that are in the water.
We can do that, and we make our technology rapidly deployable so that that's possible. Because what we want to see is more and more of these out, and so the goal is to be as modular, as easy to attach to anything that floats.
Anywhere. Isn't that amazing?
It's pretty exciting. It keeps us all excited at MarineLabs for sure. The team loves building it, and there is, there's opportunities in ports in South Pacific Islands, in other Pacific ports. All the ports in the world could be making use of this initially, but also the Coast Guard's gained value as well, because now we've got an instrument on the aid to navigation. It's a big job to handle 10,000 of these things, and so to have an instrument that says, hey, this is my GPS location, and it keeps calling in. And if it wanders, MarineLabs is able to trigger an alarm that says, look, buoy number XYZ is run away on you. You might want to check. And other things, verification of that aid to navigation is operating. And so that's another value that we provide as well.
Third and final break. We'll be right back.
The production of this program is made possible thanks to the support of the following and viewers like you.
Okay. Some viewers are going to say, well, how'd you come up with this idea? What made you want to do this? And then how did you roll it out?
Yeah, so I'm a mechanical engineer. I was undergraduate at UBC and then graduate degrees at University of Victoria, and I studied ocean engineering. So this is where you design machines that move in the ocean, and it sort of overlaps oceanography and designing things. And how do you design things to handle the ocean? And so really studying that, and realized that after I finished those degrees, I became a consultant and realized that there was a gap in the industry, primarily from the coastal engineering sector, where there was a need to get validation data quicker because projects were getting held up because the legacy equipment wasn't providing data, wasn't available, or too challenging to deploy. And so initially our solution was about serving the coastal engineering industry. And then I started talking to vessel pilots and ports and realizing there's a more interesting, faster opportunity right now, and where the data is really needed. And so that's how that kind of trajectory happened. So we started forming our product to help vessel pilots and port operations in order to get that near-term opportunity, but still serving that coastal engineering and that climate adaptation, other opportunity.
How did you figure out the technical aspects of it? Because as you're speaking, I'm thinking, okay, I get all of that, but you're talking about electronics that you're putting in the water. And as I understand it, electronics don't generally like water.
Yeah, it's not an easy project. Effectively, I studied how to seal things, right? And so we're talking about really rugged, and you may have gone on sailboats, you're thinking, how do they keep the boat from leaking around where the moving parts are and various other aspects. Well, there's a whole field of engineering to that, and so we just apply those principles and a lot of testing and a lot of care for making sure that instrument can pass all these testing, submergence, shock, impact testing, and so with testing, you can gradually get to a machine that you feel can handle these conditions. And then electronics, we're in an exciting age where electronics, you may have heard the buzzword IoT, Internet of Things, where you can have an internet-enabled circuit board at your house in 2 days if you just click order, and it costs you $40. So there's an opportunity to combine that prevalence of those types of technologies and miniaturize, and then combine that with the ocean engineering side, which is the analysis of oceanography and the data analysis in that, but also the machine design. And so that's where this all came to be, and I came up through university with a unique combination of those skill sets. And then my team now handles all of that, and they're incredible.
Wow. So how many buoys do you have in the water right now? Like, I know you said that, but...
Yeah, so 36 now. We're looking for 100 by the end of the year. We have a lot of new opportunities where these things can go and serve different communities and different users.
What happens to you if all of a sudden, you know, the government of California says, we like this, we want them up and down our coastline? Are you in a position where you can start to meet that kind of demand?
Absolutely.
Wow.
Yeah, we've designed the system to be scalable. I mean, that's the sort of buzzword in if you're starting a company, a technology company. Is it scalable is the big question you get. And so the way we've designed this is we can start a process where we could be building hundreds of them very quickly. And then we could scale to thousands quite easily. So we've very tight control on the manufacturing, very tight control on the supply chains, and very, very careful management of the process for assembling it as well.
So just to come back to the business model, because I'm somewhat fascinated by it, in essence, you're really data as a service.
Yeah, that's correct.
Yeah.
Yeah. There's other companies that are doing this. There's a very successful space company called Planet, and they started by putting shoebox-sized satellites in space and then selling pictures of the Earth with those satellites. And the satellites are a bit bigger now, but they have hundreds to thousands of satellites, and they can sell data products like a daily picture of your farmer's field if you happen to be a farmer. So this is a really
for remote sensing. Yeah.
Exactly. This is a really interesting business model, because the farmer can, or an analyst who's working for the farmer, or an agriculture consultant, or et cetera, can just log in and receive that data rather than trying to commission a new satellite. So we felt that model, there's a room for that model in coastal, and that's where that was inspired from.
Okay, how many people you got working for the company now?
So we have 14 now.
Already?
Contractors, yeah.
And who knows, huh?
I think we could be double pretty quickly in terms of size. But our goal is really to do a great job being a partner with our customers that we have, and make sure that the reliability of the service we provide is very, very high. So I mentioned the downtime issue with the existing networks. For us, it's all about uptime. And so we have 95% uptime on our whole fleet to date, and we're looking to get that to 99%. So this is something that the data is going to be there. That's the way we treat this. That's what our mission is.
The more we talk, the more excited I am for you. And it's a reflection of great innovative thinking that is based here in British Columbia, which I'm a big cheerleader for. Congratulations on getting this to this point, and I want to be watching from the sidelines, cheering you as you move forward.
Awesome, thank you.
Yeah, thank you very much for your time today. This is really, really fascinating, and I wish you great success.
I appreciate it.